Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarifan bin Muhammad Fandi. I'm from Section 5, SEMM 2713, Manufacturing Process. Today, I would like to present my individual assignment which is the topic is conducting polymers. This topic was assigned for me from my lecturer. So, without further ado, we go to the first slide. Okay, we go to the basic polymer. What is basic polymer? As we all know, polymer is an organic substance that composed of a very large number of molecules. They form a long chain where repeated molecular units are connected with covalent bond. So we can see here in the picture, there are long chains of the same molecule formed. And the second picture, we can see if it's single like this, we call it monomer. Then they experience polymerization, then it will create a long chain that we call it as a polymer. So what is the mechanical categories of the polymer? We have three here, which are rubbers, or we call it elastomer, plastics, and fibers. And generally, polymers are insulated. Why? They cannot conduct electricity. It is because they are connected with covalent bond. We all know that covalent bond doesn't have free moving electron. So because of that, it can't conduct electricity. For example, we call it polyethylene. Polyethylene is the general polymers, and they are insulator. Okay, we go to the next slide, which is conducting polymer. What is conducting polymer? Before this, we said that polymers generally cannot connect electricity, or we call it as an insulator. But these polymers can conduct electricity, or we call it as conducting polymer. What is conducting polymer? I said before, polymers that can conduct electricity. And then polymers that generally with high crystallinity are more commonly develop conductivity. From this picture, we can see that the conducting polymer is divided into three categories, or three types of conducting polymer, which are intrinsically conducting polymer, or we call it as ICP, extrinsically conducting polymer, ECP, and coordination or inorganic conducting polymer. So I'm going to explain you these two types of conducting polymer. ICP divided into two, which are conducting polymer have conjugate pi electron in backbone, and doped conducting polymers. Doped conducting polymers are divided into two also, which are p-doping and n-doping. What is p-doping? What is n-doping? Later we will discuss about this. And ECP also divided into two categories, which are conductive elements filled polymer and blended conducting polymers. Basically, these two types is just like the same, but we have a different explanation on these two. So we go to the next slide. ICP, or intrinsically conducting polymer. It is made up of extensive conjugate system that contain solid backbone to act as conductive. Okay. Conducting polymer having conjugate pi electron in the backbone. What is pi bond? Pi bond is a cloud of electron that have in the ICP. Due to the cloud of electron, it having an ability to conduct electricity. This electron can flow from one point to another point, and that is why conductivity occurs. And we can say that ICP is responsible for electrical. We can say that the pi electron in the backbone is responsible for electrical charge influenced by electric field conjugate pi electron, and overlapping of orbital of conjugate pi electron over the entire backbone, resulting in conduction band and the formation of valence bands. We can see the pictures here, which example of polypyrrole. Polypyrrole is one of example of ICP. Okay, next. Second one is dope conducting polymer. Dope conducting polymer is the conducting polymers obtained by exposing the polymer to a charge transfer agent in either gas phase or in solution. Doping. What is doping? Doping is a process to increase conductivity of the polymer by creating positive or negative charge through oxidation or reduction. Okay, we go to this more detail, but not too detailed. So p-doping. What is p-doping? Why we call it p-doping? P-doping simply means that positive doping. Why? Because it is done by oxidation process and with used of Lewis acid. So we call it positive because Lewis acid provide the solution here, a cation. Anion. Anion is the positive charge of ion, right? So because of that, we call this p-doping, which is positive doping. You can see the formulation here, or the equation here. Polyethylene, we add Lewis acid, or we call it as agent anion, for ion, a positive ion, and then we will form p-dope polyacetylene. And n-doping is just the opposite of p-doping. N-doping we call is n-doping because negative doping. It is done by reduction process, and Lewis base. Lewis base is the opposite chemical of Lewis acid. Lewis base provide cation, which is negative ion. So from the equation here, polyacetylene, we add Lewis base and it will form n-dope polyacetylene. Okay, so next slide. What is the advantage and limitation of ICP? The advantage of ICP are ability to store a charge, ability to undergo ion exchange, ability to observe visible light to give colored product, and last one is transparent to X-ray. And the limitation of ICP are their conductivities are poorer than metals. We also know that metals is the good conductor and the best conductor, and poor of mechanical strength, less stable at high temperature, and it tends to lose in conductivity if they are on storage. Okay, next. So we go to the ECP, or extrinsically conducting polymer. So the explanation is this polymer owe their conductivity due to the presence of externally added ingredient in them. So as we all know, before I showed the picture, ECP is divided into two. So the first one is the conductive element filled polymer. It is polymer act as a binder to hold the conducting elements together. What it is? It simply means that conductive element filled polymer is we add conductive element into the polymer itself. So minimum concentration of the conductive filler that added in order to let the polymer start conducting, we call it as percolation threshold. Okay, what is the important characteristic of ECP? It is the important characteristics are possess good conductivity, they are cheaper, light in weight, mechanically durable and strong, and easily processed to different form, which are sizes, such as sizes and shapes. And next one is blended conductive polymer. It is likely the same as before, as conductive element filled polymer. And explanation is it obtained by mixing conducting polymer with typical polymer, either chemically or physically. So conductive element polymer, we add conductive element into polymer, but blended conducting polymer, we add conducting polymer into typical polymer. So the difference is here, which is we add conductive polymer in blended conducting polymer, but in conductive element fit polymer, here we add a conductive element into a polymer. So it is easily processed and perform better mechanical, physical, and chemical properties. Okay, here the application of conducting polymer. You can see I state 4 of the applications, and the picture here. It can be used as an anti-static substance for photographic film, as a compact capacitor, as electromagnetic shield for computer, and as a LED, light emitting diode. So the conductive polymer is very useful and widely used in many fields. So we go to the conclusion of this topic. In order to have we need a good conductance, we must have free electron. Without free moving electron, there is no conductance or conductivity. And we can compare the conductivity of conductive polymer and metal. For metals, the higher temperature, the increased temperature will increase the conduction of the metal, but different to the conductive polymer. Conductive polymer will decrease with falling of temperature. And nowadays, we all know that conductive plastic or conductive polymer are being developed for widely uses. Okay, that's all from me, and thank you very much. Assalamualaikum warahmatullahi wabarakatuh.